Hello students, howdy! Let's talk about the periodic table. I know you've thought about it before, I know you've used it before, and you probably thought, it just happened. I can guarantee that Tetris is not how we came upon the periodic table. Don't believe all jokes on the internet. Maybe if Mendeleev had Tetris, that would have been the case, but he didn't. Let's talk about how they did come to discover the periodic table. The periodic table is used to show patterns in properties, sometimes called PT. Elements can share properties. They're not exactly the same, but elements can be the same phase. Elements can show the same color. They can have the same reactivity with oxygen and chlorine, other elements, whether or not they form salt, the number of valence electrons, and many other things are all shown on the periodic table. But how did we get there? Let's talk about our boy John Newlands. In 1860, America's fighting the Civil War, but there's an English chemist who knows about 60 elements, and he wanted to organize them. He thought it was a good idea. He came up with the law of octave. In the law of octaves, he placed the elements in a table. He arranged the elements by property and by mass, and noted that the properties repeated every 8 elements, roughly. Elements in the same row had the same properties. That's how we set it up. And it looked like this. So, if we're talking rows, you see some things like lithium, sodium, potassium. These have similar properties. Carbon and silicone have similar properties. Oxygen, sulfur have similar properties. So there's some things they have in common, but it wasn't perfect. However, Dmitri Mendeleev took that research, that organization, to the next step. He was a Russian chemist. He looks like a Russian chemist, I think. And in 1869, he was doing great work. What he did is he started with Newlands research, that they have similar properties, but he ordered them in a nice, orderly arrangement. And he used all 63 elements known to them then. He used symbols and atomic masses as well as properties. Sounds familiar? And he left gaps where he suspected elements should be. You can see this does not look exactly like our periodic table, but you can see some similarities here. We notice hydrogen and lithium are in the same group. Lithium's grouped with sodium. Potassium is grouped with lithium and sodium. However, you see some question marks here. He suspected there were some elements here, but he wasn't quite sure they were there. But again, this is arranged by atomic mass. He had a second attempt in 1871. This worked a little bit better. He had their reactivities with oxygen or with hydrogen, which actually is part of how they're organized now. Again, they are arranged in nice columns. A few notes on Mendeleev's table. It organizes things in both groups and periods. Groups are vertical. They're going to be like, let's see here. They're going to be like this. Groups go up and down. Groups go up and down. Sometimes they're also called families. And these share properties, reactivity, number of valence electrons. We'll get more into that later. Periods are horizontal. They're going to go left to right. Periods are like rows, and they increase by mass. And different periods are going to have different energy levels. We're going to get there again later. And he left space for the unknown elements. He called them ekas, which means close to, and by 1886, all three had been discovered. He was absolutely right with his predictions. This is why we make hypotheses, use data, make hypotheses, because they need to be tested out later. That's what he did. Mendeleev was the man. And he came up with the periodic law. The table is periodic. It's based off of repeating trends and properties based on increasing atomic mass. The periodicity is the periodic law. That's different than the law of octaves, where there was just 8 together that had some properties. If they have properties and they're based on increasing atomic mass and repeating trends, that's the periodic law. And then Moseley comes along. In 1913, he's another British chemist, and he worked with Rutherford. Oh, we remember him. He discovered the proton with his Gold-Floy experiment. Remember, well, he did other things too. But one of the things he had was the solar system model, which had the electrons arranged around the protons in the center. And Moseley examined the spectra, which is basically he shot X-rays at different metals and saw what they gave off. And he noticed a pattern that worked better for a periodic table, and he organized them by atomic number. Because atomic number, remember, is protons instead of just the atomic mass. And the atomic number is the basis of periodicity. And it helped to support Mendeleev's arrangement and resolve discrepancies in his arrangement, but again, it's not the atomic mass. This is one major discrepancy. Cobalt has an atomic number of 27. Nickel has an atomic number of 28. They come after each other. Nickel comes after cobalt. However, the atomic mass, the average atomic mass for cobalt is 58.93, and the average atomic mass for nickel is 58.69, which is not how Mendeleev had his set up. So this is a great example of how the periodicity is actually based on the atomic number, not the atomic mass. Other modern trends that we see is periods have similar energy levels. I'm going to show you what that means, and similar electron configurations. We'll get into that later as well. Remember, periods are the rows. Periods are the rows. Families and groups, these go up and down. There is the S, P, D, and F block elements, which have to do with electron configuration. And there's a number of valence electrons, which is really important for reactivity. It's why things bond, which we'll get into later. But those can be very, very easily predicted using groups. And remember, valence electrons are electrons found in the outermost orbit of an atom. So if this is an atom, and these are the energy levels, we can see several energy levels. There's 1, 2, 3, 4, if we assume that the nucleus is in here. Well, those are the energy levels, and the number of energy levels in the atom can be predicted by the period. However, valence electrons, the number of valence electrons, which are again the electrons in the outermost energy level, those have to do with the groups. These are valence electrons. And we know that this would actually be in group 1 because there's only one valence electron. Let's talk about that a little more. So, groups. Groups go up and down. So, major groups are 1, 2, 13, 14, 15, 16, 17, and 18. And that's important because it helps you predict number of valence electrons. Group 1 has 1 valence electron. Group 2 has 2 valence electrons. We're going to skip through these because they're actually not 100% predictable, but we do get predictable again by group 13, which is 3 valence electrons. 14 is 4, 15 is 5, 16 6, 17 7, and group 18 has 8 valence electrons. They're actually quite happy because they're noble gases out here. And I guess I do want to point out that helium is happy. It has a filled shell, but it really belongs over here for a lot of these trends. But we'll talk about that a little more. Let's talk about S blocks, the different blocks. So S blocks, that's the innermost energy level, are going to be filled here. These are S block elements. Then we have our p block elements. This is through 8. Again, helium goes over here. There's 6 more electrons that could go in here to fill with 8. Then we have our D block. This is our transition elements. And then we have our F block, our inner transition elements, which we will talk about more later. And now periods. Remember, groups went up and down. Periods go left and right. Talk about period 1, right here. Period 2, right here. 3, 4, 5, 6, and 7. This is 1, 2, 3, 4, 5, 6, and 7. And these are important because these give us the number of energy levels. So we know sodium actually has 1 circle, 1 energy level, 2 energy levels, and 3 energy levels. And we can figure that out. I'm going to show you several ways to figure that out by filling energy levels. But we can just look quickly at sodium and know that it has 3 energy levels, just like everything else in this period. If we go down here to calcium, we know it's got another energy level because it is in group 4. And we'll practice this more. And I really, really hope that was helpful.